Hello, distinguished viewers all over the world. Welcome to Simplified Maths class once again. I am your host, Mr. Mike Omini, and today we'll be taking the topic direct and inverse variation. But before we proceed, if you have not subscribed to our channel, please kindly do us the favor by clicking on the red subscribe and the bell notification. God bless you as you do that. All right, so direct and inverse variation. For direct variation, we are trying to look at the relationship that exists between two variables in the positive direction. The variables could be x and y. And if you're trying to solve problems that involve direct variation, understand that the two variables move in the same direction. All right, which means that an increase in one of the variables will result to a corresponding increase in the other variable. And of course, it means that a decrease in one of the variables will result to another decrease in the other variable in the same proportional measure. So that's what direct variation or direct proportion is all about. But for inverse variation or inverse proportion, understand that there is a negative relationship that exists between the two variables. Unlike the direct, where there is a positive relationship, for the indirect, there is a negative relationship existing between the variables, meaning that an increase in one of the variables will result to rather a corresponding decrease in the other variable, and a decrease in the first will result to a corresponding increase in the second, and vice versa. Okay, so that's what direct and inverse variation is all about. So we are going to be having two examples each to try solving on the board, so that with those two examples, any example you see or any question that comes your way, you can be able to solve it. All right, so we have one question on the board and it said if P varies directly as Q and P is 12 when Q is 3. First and foremost, look for the constant of variation. We call it the constant of variation or the constant of proportionality, because variation and proportionality are the same thing. And then we should find P when Q is half and Q when P is 20. All right, so the first thing, I want to find the constant of proportionality. So P varies directly as Q. All right, that's a direct variation. And then, which means that P will be equals to constant of Q. So for the direct variation to change to equality sign, you will introduce the constant of variation or the constant of proportionality. Please take note of that. That's very important. All right, so which means that the first thing we have to find is the K based on the first statement. They say if P varies directly as Q, when P is 12, Q is 3. When the P is 12, all right, the Q itself will be 3. That's what it means. So we have that 12 is equals to constant times 3. So if 12 is equals to K3, we want to make the constant K, all right, the subject of the formula. And that K is what we call the constant of variation. So 3 cancels 3. So our K will be equals to 12 divided by 3, which is 4. Therefore, the constant of variation equals 4. The constant of variation equals 4. So that's our constant of variation, which is 4. So we need now to know the formula connecting them. The formula that connect, the formula connecting P and Q. So for us to know the formula connecting P and Q, we have to introduce this, all right, this equation I've marked, and then make K to be equals to 4, because we have computed K to be 4. So if we substitute 4 in this, we are going to have the formula connecting P and Q. So it means that P now will be equals to, what is our K? K is 4, 4Q. So this is the formula connecting P and Q. So once you have the formula connecting P and Q, you can solve any other question they ask. Say for instance, the second one, they say we should find P when Q is half. So to find P when Q is half, it means you will bring out this, which is P now is equals to 4 times Q. All right, and now they have given us the Q to be half. So P now will be equals to 4 times Q now being half. So we are going to have P to be equals to 4 times 1 is 4 all over 2. So 4 divided by 2 will give us 2. It means that to find P when Q is half, P will definitely give us 2. So P will be 2 when Q is half. It's that simple. So when once you have gotten the formula connecting them, it's quite easy to find any other problem that follows. All right, so let's take the second one. There is a second problem that follows. Now they want us to find Q when P equals 20. All right, so we bring it out. To find Q when P is equals to 20, you still have to bring out the formula connecting them. All right, so the formula connecting them is P is equals to 4Q. Now we want P to be 20, so P is 20, and that will be equals to 4 times Q. Now it means 4Q equals 20. 4Q equals 20. So what will our Q be? All right, so we divide through by 4. So if we divide here by 4 and divide here by 4, we are going to have what we are looking for. All right, so you say 4Q is equals to 20. Divide by 4, divide by 4. So we'll have our Q to be equals to 20 divided by 4, which is 5. So it means that to find Q when P is 20, when P is 20, Q will definitely be 5. All right, so notice that we have direct variation here. How do you know? Okay, let's go back. So this is P and this is Q. When P was 12, Q was definitely 3. All right, here, when P is 20, Q gave us 5. And here, when P was 2, all right, Q itself was half. So notice that when P was 12, Q was 3. Now P increased to 20. Q definitely increased from 3 to 5. There's an increase on both sides. Notice that here, when P, all right, decreased to 2, definitely Q decreased to half. So in direct variation, an increase in one of the variables becomes a corresponding increase in the other variable, and a decrease in one becomes a corresponding decrease in one. So that's what direct variation is all about. So that's one problem. Let's try a second problem before we take inverse variation. So we'll be trying a second problem. All right, with that we will now understand that at least we have done something tangible for the direct variation before we introduce the inverse variation. So let's take a problem. Let's say, for instance, if A varies directly as the square root of B. Number 2, if A varies directly. Sometimes you may not see vary directly. They will say if A is directly proportional. So anytime you hear direct variation or direct proportionality, it's the same thing. All right, so let's use that term. If A is directly proportional, let's use that word so that we'll know they mean the same thing. Proportional to the square root of B. We are saying that if A varies directly as the square root of B, and let's say, for instance, if A is 5 when B is 100, and if A is equals to 5 when B is equals to 100, all right, so the answer we should find, let's say, for instance, without necessarily writing the constant, we can be asked to find anything we want to find. So let's find, let's say, A when B is 36. Find A when B is equals to 36. And let's say, for instance, let's find maybe B when A is 4. Let's find B when A is 4. All right, solution. Let's see how we can do this. It's still a direct variation or a direct proportional problem. All right, so we take it. A varies directly as the square root of B. So this is equals to the square root of B. Take note of that. All right, so we need to bring the constant. By changing the proportional and sign to equality sign, we introduce a constant. Therefore, A now is equals to a constant of the square root of B. All right, please take note of this, because with this you can be able to get the formula connecting A and B. All right, so they've said, and A is 5. A here is 5 when B is 100. So B is 100. We want to find the constant of proportionality. So 5 now will be equals to a constant of the square root of 100 is 10. Alright, so 5 is equals to 10k. K times 10 will give us 10k. And we want to make k the subject of formula. Okay, so we are going to have 10k. To find k, we divide both sides by 10. 10 crosses 10. Therefore, our k will be equals to 5 over 10. 5 here, 1, and 5 here, 2. So our constant of proportionality is 1 over 2, which is half. So you can either use 1 over 2 or you use 0.5. Whichever one, it will work for you. Alright, now we've been able to have this. So we can now bring out the formula connecting them. So the formula connecting A and B. The formula connecting A and B will be to bring out this and make k to be half. So that will be A is equals to half of the square root of B. So that's the formula connecting them, where k is half. So you only substitute k is half. With this formula connecting them, you can find any question they ask. Alright, which is here. So they say we should find A when B is 36. Alright, so to find A when B is 36, meaning that we are going to have A is equals to half of B. The square root of B. The square root of B is 36. So we have the square root of 36. So our A now will be equals to half of the square root of 36 is definitely 6. Alright, so our A will be equals to half of 6 will give us 3. Alright, so our A, which is half of 6, will give us 3. Alright, so our A is 3. Is that simple? So we've been able to find 1. Okay, so now we need to find the second. Now we need to find the second one. And in the second one, they say to find, this time around they say we should find B when A is 4. To find B when A is 4. The first one was to find A when B is 36, which is what we just did here. We've gotten A. And this time around we want to find B when A is 4. That's why we wrote to find B when A is 4. We still need to bring the formula connecting them, which is A is equals to half of the square root of B. So A is 4. So A is 4. 4 is equals to half of the square root of B. The square root of B. We want to find the value of B. Alright? So this will give us 4 is equals to half of this will give us root B divided by 2. That's what it means. Half of this meaning root B divided by 2. So we make this over 1 and cross multiply. Root B times 1 will give us root B is equals to 2 times 4 will give us 8. So we've gotten our root B to be 8. Now for us to find B alone, we square both sides. So we have root B all squared will be equals to 8 all squared. Because it's only through that way that square now will cancel square roots. Therefore, it means that our B will be equals to 8 squared, which is 64. Alright, so we've been able to have our B, which is 64. And if you check, from the beginning they said if A is 5, so this is A and this is B. They say if A is 5, B was 100. So let's see what happens. This time around, when A is 4, when A is 4, B gave us 64. Alright, and this time around, when A is 3, B gave us what? B gave us B was half. No, sorry, B was 36. When A is 3, which is 3, B was 36. Alright, so again, if you look at it, you see that we are dealing with direct variation or direct proportionality. You can see that at 5, when A was 5, B was 100. A reduced to 4, B reduced to 64. A reduced to 3, B reduced to 36. So you can see that they move in the same direction, meaning that an increase or a decrease in one gives you decrease in the other. Decrease in one gives you decrease in the other. Increase in one gives you increase in the other. So that's what direct variation is all about, which is what we call direct proportionality. Alright, so we are through with the direct. Let's try 2 problems on the inverse variation to see how the inverse variation is. Inverse variation. Alright, so we need the inverse variation this time around. In the inverse variation, we have already told you that where you're trying to look at 2 quantities that are related, alright, 2 variables that are related, an increase in one of the variables will result to a corresponding decrease in the other variable and vice versa. That's what inverse variation is all about. So let's take an illustration. For instance, let's say if let's say y varies inversely as the square of x. Number one, if y varies inversely as the square of x. If y varies inversely as the square of x, let's say, and y is 4, let's say when x is 3, and y equals to 4 when x is equals to 3. We can be asked to find y when x is 2. So find y when x is equals to 2. All right, here they only give us one thing to find, but let's see how to apply. Solution. Now in inverse variation, we're told that y varies inversely, meaning you have 1 all over. That's the meaning of inversely. Inversely as the square of x. Square of x, that's x squared. That's the square of x. So y varies inversely as the square of x. That's inverse variation. With this, we can be able to introduce the constant of proportionality by changing this to equality sign. So y now will be equals to a constant of what? 1 all over x squared. A constant of 1 all over x squared. Which means y will be equals to k times 1 will give us k all over x squared. Please take note of this. When we are trying to look for the formula connecting both variables, we will still bring out this, just as we've been doing. Now they now say, and y is 4. Y is 4. K all over when x is 3. When x is 3. So you have x being 3 before the square. Very simple. Alright, so which means 4 now is equals to k all over 3 squared being 9. So we make this over 1 and cross multiply. K times 1 will give us k is equals to 4 times 9. 4 times 9. And of course, k will be equals to 4 times 9 will give us 36. So 4 times 9 will give us 36. Take note of that. So we've been able to get the constant of proportionality. So now we need to have the formula connecting both of them. The formula connecting x and y, or connecting y and x. So we need to get the formula connecting y and x by bringing out this in the box. So we're told that y is equals to k all over x raised to power 2. But k has been calculated as 36. It therefore means that instead of having k here, we are going to have 36 all over x squared. And that's the formula connecting y and x. With this formula, you can find any other thing that follows. And here they say we should find y when x is 2. So to find y when x is 2. Alright, so we are going to have that. Our y will be equals to 36 all over. Our x is 2. So that will be 2 squared. So y will be equals to 36 all over 2 squared is 4. Alright, so which means our y will be equals to 36 divided by 4. That gives us 9. As simple as it is. So we've gotten our y. Now, how do we know if what we've just done is an inverse variation or inverse proportionality? Alright, so remember that they say y is 4. So we have y and x. They say y is 4 when x is 3. Take note of that. But now, okay, when x is 2, alright, what did y give us? Y gave us 9. Now look at it, you see that it's an inverse variation. When x was 3, y was 4. But this time around, when x now decreased to 2, but y rather increased to 9. Take note of that. When x decreased from 3 to 2, y rather increased from 4 to 9. You can see the relationship is a negative relationship. That's what inverse variation is all about. It means both variables are going in different directions. They have a negative relationship. And that negative relationship is what we call inverse relationship or inverse variation. Please take note of that. Alright, so let's try the last one, the last example in inverse variation. let's try another example in inverse variation. At least we have two examples in the direct variation. Let's try two in the inverse so that we will be on the same page. All right, so number 2. Assuming they say that maybe S varies inversely as the cube of t. S varies, or S is directly proportional. If S is that or inversely proportional, if S is inversely proportional to the cube of t, if S is inversely proportional to the cube of t, and then maybe S is 50 when t is 2, and S is equals to 50 when t is equals to 2. All right, so we should find maybe S when t is 5. So find S when t is 5. All right, so let's try this. This is also an inverse variation or inverse proportionality. So S varies inversely as the cube of t. That means t raised to the power of 3. That's the meaning of cube of t. But if they say cube root of t, that is, this is cube root of t. But they say cube of t, that's t raised to the power 3. Please don't forget that. All right, so we need to introduce a constant of proportionality. S will be equals to a constant of what? 1 all over t raised to power 3. So that gives us S now to be equals to k times 1 is k all over t raised to power 3. And of course, this is important in knowing the formula connecting S and t. All right, so they now say that S is 50. So S here is 50 is equals to k all over when t is 2. When t is 2 raised to power 3. Because we're having t raised to power 3. So, all right, so this will be 50 is equals to k all over 2 raised to the power of 3 is 8. So we'll make this over 1 and cross multiply. K times 1 will definitely give us k is equals to 8 times 50. K times 1 is k. 8 times 50. So we are having 8 times 50. And of course, k will be equals to 8 times 50 will give us 400. So having k to be 400, we'll substitute the k here. We can now have the formula connecting them. The formula connecting them, the formula connecting S and T will be to bring out this. We were told that S is equals to k all over t raised to the power of 3. But we have calculated the k now to be 400. So we remove k here and substitute with the 400. So this is the formula connecting S and T. And with that formula, you can solve any other thing. So we have to find S when T is 5. To find S when T is 5. To find S when T is equals to 5. So we are going to have S is equals to 400 all over T being 5. So that will be 5 raised to power 3. So our S will be equals to 400. 5 raised to power 3 is 5 times 5 times 5. And of course, that will give us 125. Alright, so our S now will be equals to divide 400 by 125. I think that should be 3.2 or thereabouts. 400 divided by 125. 3.2, right? Yes. So that will be 3.2. It therefore means that S will be 3.2, of course, when T is equals to 5. So we are through with the inverse variation. Direct variation. They are that simple, very simple to work on. Before we go to other variations in our next slide, please do not forget to click on the red subscribe and on the bell notification. And if of course you enjoyed our class, direct and inverse variation, don't forget to give us a like, a thumbnail. And if you have any question whatsoever that pertains to direct and inverse variation, don't forget to drop your question in the comment section. And of course, if you enjoyed the class, you can also drop your comment down in the comment section, and we'll definitely get back to you. We'll respond to your question or your comment as the case may be. God bless you once more for subscribing to our channel. You are a professional mathematician, and we're glad that we are going to make you one. And we are glad that we'll make you a better mathematician. All right, have a wonderful day until we meet next. I still remain the host, Mr. Mike Omini. Cheers.